Okay, now we're going to work with simplifying radical expressions, and we're going to be learning a lot of different properties that the radicals have. So we need to really pay attention to these properties. These are going to be hugely important. If you want to make a list of them as you go so that you have something that you can refer back to very quickly and easily, that would be great. This first property that we're going to talk about is the product property of radicals. Now remember, product meaning two things you multiply together. So this one says if you've got a root, the nth root of A and the nth root of B, and these are real numbers, and it also says that n is greater than or equal to 2, meaning we're working with the square root or higher. The first root is, there's no point in it, so they're just making sure that their definition is very, very precise. Then it says if you can multiply these two roots as long as that index is the exact same, and we can just multiply what's underneath the radical. So basically your rule says if your indexes are the same, you just multiply the radicands. So let's see how this works. Do a few examples here. Here we have one that says the cube root of 6 times the cube root of 10. Now because our roots, our indexes, are the exact same thing, or indices I guess would be the proper plural of it, our rule says we can just multiply the radicand. So this would be the same thing as saying the cube root of 6 times 10. And then we can simplify 6 times 10 into 60. So that would be the same thing as saying the cube root of 60 using that product property. Okay, here we have one that looks a little bit more complicated, but again, we are multiplying roots that have the exact same index. Remember, since it's not stated, this is understood to be a square root, and this is understood to be a square root. So because of our property, it says we can multiply the radicands. So this would be the same thing as saying the square root of 5x over 3 times 3 over x, all underneath that same radical symbol. And now we can apply our properties of fractions, rational expressions, in order to simplify it. We've got a 3 on top and bottom that we can cancel out that common factor. We also have a common factor of x on top and bottom that we can cancel. So all we're left with now is just the square root of 5. So that is as simplified as that multiplication can get. Here we have one that has, looks very different because it's got two terms underneath the radical. But again, our rules are the same. If the index is the same in both of these radicals, we can simply multiply the radicands. So I would multiply this as the square root of p minus 5 times p plus 5. Now we can simplify this because this is just binomials, and we can multiply those together. So if I multiply those together, we'd have p times p is p squared, and then we would have a plus 5p minus 5p would cancel out, and then negative 5 times positive 5 would be negative 25. Now we cannot take the square root of each individual item. That's not allowed. Since we're dealing with terms there, we can't just pick and choose what we're doing the square root of. So actually our answer has to be the square root of p squared minus 25.